See what the field of view looks like. You're backing into the cable.
It will come very close to Mars on October 3rd. These objects might be a spacecraft, it's not a rock.
NASA has confirmed it. A mysterious emerald comet from another star is racing toward our solar system. On October 3rd, 2025, it will brush past Mars, offering orbiters the closest look yet at an interstellar visitor.
3IAtlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Weeks later, it will dive toward the sun at breakneck speed. But unlike any comet before, this one carries a glow that no one can explain. The glow that shouldn't exist. It began quietly, almost by accident. On the night of September 7th, 2025, the skies dimmed under a total lunar eclipse. The moon turned blood red, telescopes across the world tilted upward, and cameras clicked. But in the background, something else appeared, an object that refused to behave. At first it looked ordinary, a faint, icy blue smudge. Then, over just a few hours, its coma exploded into a vivid emerald halo, stretching tens of thousands of kilometers into space. Amateur astronomers in Austria and Namibia were among the first to capture it. They posted images online, and within hours the world of astronomy was in shock. The color shift was too abrupt, too intense, too unnatural. Comets can glow green when dicarbon molecules, C2, fluoresce in sunlight. But this wasn't the same. The hue was wrong, the brightness was orders of magnitude too high, and the timing, mid-eclipse, defied explanation. Veteran observers double-checked their filters, recalibrated their sensors, and reprocessed their data. Each test came back the same. The green glow was real, and it wasn't fading. Across forums, Slack channels, and observatory chat rooms, the same question echoed: what could possibly cause a comet from another star to glow this way? A messenger from beyond the sun's grasp. The story of 3IAtlas really began 2 months earlier, on July 1st, 2025. At the Atlas Survey Telescope in Rio Hurtado, Chile, software designed to spot fast-moving near-Earth objects flagged something unusual, a faint dot streaking across a crowded star field at 61 kilometers per second. The orbit didn't fit. It wasn't looping around the sun like an ordinary comet or asteroid. Instead, its path was hyperbolic, open-ended, mathematically unbound, a signature of something not born here. By the time the Minor Planet Center confirmed the discovery and issued its circular, the astronomy community already knew this was history. After Oumuamua in 2017 and Borisov in 2019, this was only the third interstellar object ever seen. But almost immediately, 3IAtlas began rewriting expectations. Unlike Oumuamua's cigar-shaped mystery or Borisov's normal cometary behavior, this visitor carried chemistry that belonged nowhere in the solar system. Chemistry from an alien cradle. As spectrographs around the world locked on, the surprises came fast. Carbon dioxide dominated. In most solar system comets, water is the main driver of activity, with CO2 as a faint secondary gas. Here, the ratio was reversed, 8 parts, CO2 for every 1 part water. C2 swan bands were absent. Normally, they're the hallmark of a green comet, yet 3IAtlas glowed brilliantly emerald without them. Carbonyl sulfide appeared, rare even in the most exotic comets. This molecule stood out. And most shocking of all, the spectrum glowed with 22 distinct emission lines of atomic nickel, but almost no iron. In our solar system, nickel and iron are inseparable twins. They're forged together in stellar furnaces, locked in mineral grains, released together by heat. For nickel to appear alone was unheard of. Some researchers whispered about volatile organometallic compounds, molecules binding nickel to carbon structures that could sublimate in cold alien environments. Others pointed to protoplanetary disks around distant stars, where chemistry might play by entirely different rules. Whatever the explanation, the message was clear. This was a world shaped by conditions unlike anything in our solar system. The impossible polarization. Then came another shock. In July 2025, the William Herschel telescope in the Canary Islands recorded something no one expected: the strongest negative polarization ever measured in a comet. Polarization measures how dust grains scatter light. For decades, astronomers have built catalogs of comet behavior, from Halley to Hale-Bopp. But 3IAtlas plunged off the chart, echoing not comets, but distant trans-Neptunian objects, icy relics that have remained untouched since the birth of the solar system. If the data was right, the dust swirling around this interstellar traveler wasn't like ours. It carried a fingerprint billions of years old, born in the cold cradle of another star. Eyes turned away. Ironically, just as the mystery deepened, Earth's best eyes would be forced to look away. Both Hubble and the James Webb Space Telescope are designed with strict safety protocols. Neither can point too close to the sun without risking permanent damage. And as 3IAtlas approaches perihelion on October 29, 2025, it slips directly into that forbidden zone. The timing couldn't be worse. At the very moment the comet is likely to reveal its most intense chemistry, Earth's flagship observatories must stay blind. But there is a backup plan. On October 3rd, as 3IAtlas sweeps closest to Mars, just 29 million kilometers away, a fleet of orbiters, MRO, MAVEN, and others, will have a front row seat. Mission teams have already scrambled to retask instruments, calibrating spectrographs and cameras to capture the fleeting encounter. For a brief moment, Mars becomes humanity's outpost for interstellar science. What we almost missed. Looking back, astronomers realized how close they came to overlooking this visitor entirely. In 2023, NASA's TESS spacecraft quietly recorded faint images of 3IAtlas slipping across its field of view, but the automated pipeline never flagged it. In 2024, during its engineering tests, the Vera Rubin Observatory also caught the comet, hidden in its enormous dataset. But with science operations not yet fully online, the discovery sat buried. Only after the official July 2025 announcement did researchers comb through the archives and find the missed detections. They called it the near miss that ended the era of cometary luck. From now on, the hunt for interstellar objects would not depend on chance, but on systematic all-sky surveys designed to catch them early. A riddle in chemistry. The deeper scientists probed, the stranger 3IAtlas became. Its overwhelming carbon dioxide hinted at a birthplace far colder than the edges of our Kuiper Belt, perhaps in the frozen outskirts of a star older than the sun. Its nickel-rich, iron-poor gas suggested mineral processes we've never seen before. Its polarization record implied dust grains that formed under conditions alien to Earth. Each clue pointed to a cosmic origin story, unlike any in our solar system. And yet, none of it explained the most basic mystery. Why did this comet glow so brilliantly green without the molecules that should cause it? Some theorists suggested unknown radicals, molecules never before seen in space, were fluorescing under sunlight. Others wondered if exotic ice chemistries, stable only in the coldest regions of interstellar space, were breaking apart as they approached the sun. For now, the truth remains hidden inside the emerald halo. The stakes of perihelion. On October 29th, 3IAtlas will pass perihelion, its closest approach to the sun. The heat and radiation will boil off its ices, potentially fragment its nucleus, and unleash the full chemistry it has carried for billions of years. But whether humanity captures that data depends on coordination. With Hubble and Webb sidelined, the burden falls on Mars orbiters and Earth-based telescopes working at the edge of their limits. If the comet fragments, we may never get a second chance. By December, it will fade back into the black, receding into interstellar space, taking its secrets with it. What it means. In the end, 3IAtlas is more than a comet. It is a time capsule from another star, older than our solar system, carrying chemistry that challenges everything we know about planetary formation. Its emerald glow, its nickel without iron, its record-breaking polarization. Each anomaly is a clue. Together, they remind us that the rules of our solar system are not universal. Other stars forge worlds under different laws, and sometimes, those worlds send us messengers. For humanity, the arrival of 3IAtlas is a moment of rare clarity. We are not just observing an object, we are looking at a fragment of another planetary nursery, a piece of a story billions of years in the making. As it races past Mars and dives toward the sun, the question is not whether we can explain it. The question is whether we can learn fast enough before it disappears forever. Because in 3IAtlas, the universe has handed us not just a comet, but a riddle, and perhaps a warning that the cosmos still holds secrets far stranger than we are prepared to imagine.